Okay, now we're on page 94 of your workbook, example 7.14. We are going to factor m squared plus 7mn minus 8n squared. So this is a great one where you could try for classwork because it's very similar to the one that we just did in part 1. This is part 2 of this set. But I'll go through it with you as well. So I'm going to do the skeleton method, the reverse FOIL right away. So I'm going to just put my parentheses here. I know that I have a plus and a minus. So what that tells me is that I need to have opposite signs. In order to get a negative on the end, I would have to have a plus and a minus. In order to get a positive here, I have to have one of my factors, the one with the larger absolute value, has to hold the positive sign. So the first thing I'm going to do is look at my lead coefficient here. It just has a 1, right? So I have 1m squared. So I know that can split apart as m times m. And then I'm going to look at the ends, the end one. Not the ends, but just the end here. I have to make a negative 8n squared. So I know I'm going to have n times n, but how is this going to lay out? I can just kind of guess and check or trial and error. I know I need to have 7 in the middle, so I have to think about what are factors of negative 8 that will give me a positive 7. So if I think about that, I will have 8 and 1 just pops out to me. I mean, I could try 4 and 2. I mean, if I did that, let's just try one that we know is wrong. If I put a 4 and a 2 in there, I'm going to get a negative 8n squared on the end. But if I check that middle term, I would get a 4nm and a negative 2nm, which adds up to 2nm. So this would be no, right? So that's a no-go. So I would have to try another one. And I'm going to leave that there so I can get partial credit, right? So then I'm going to try again, m plus something and m minus something. And I know I need the n. And I'm just trying to figure in these, question marks. What do I want to put in there? So I'm going to try 8 and 1. So now if I put in 8 here and a 1 here, it works out 8nm and minus 1nm does in fact give me a plus 7nm. Now if I had gotten a negative 7, then I would just switch the signs on them. But this works. I get that middle term, and then I just double check that my m times n is going to give me m squared. 8n times negative n is going to give me 8n squared. So my answer, just to be sure, you want to really write your answer clearly with all these trials and errors and stuff happening. So this is my final answer. And I'm going to mark that in a box, m plus 8n, parentheses, m minus n in parentheses. And then I'm going to verify. That would be m squared minus nm plus 8nm minus 8n squared. And then combine like terms minus nm plus 8nm gives me a plus 7nm. Now 7nm is the same as 7mn, commutativity. So I'm going to write that and then minus 8n squared finally. So that is good. But notice how I keep that separate and I label what my verification is. So really good practice for that because you can really just get caught up in looking at stuff and not really knowing what your answer is if you don't track everything and label it. So just take that extra second to. I really find half the battle with math is just tracking stuff. So here's a note. The shortcut for factoring the type x squared plus bx plus c, once we identify the two numbers p and q whose product is c and sum is b, we can see these two numbers are numbers in the factored form of x plus p times quantity x plus q. We can use this shortcut only when the coefficient is 1. I will show you, I've been trying to lead you into thinking about the process and relating it to when the coefficient isn't 1. So what we are doing here is what I did above. So I want you to try this one as classwork using the skeleton if you're comfortable, just popping right in. Now notice this is different than when I split it apart to the 4 terms and then I put the parentheses around. I still have a plus in the middle to start with. This one I don't have any plus in there. I'm just jumping right to the 2 binomials being multiplied together. So it is a different process. So I would say kind of try both on your homeworks and things like that. See what you're the most successful with. And on tests, stick with 1 for tests. And then always practice being able to do both methods, because sometimes one suits you better than the other. Like if you have a lead coefficient that's a high number and it's tricky to work with, then you're really going to need to probably use the box method, the grouping, but for these simple ones you can just pop right in. So on this one, again, pause and try it on your own, and I'm going to go through it quick. I notice here that I have a middle term of negative 14x. My lead coefficient is 1. So I can just kind of jump right to the skeleton method. I have my C is 48. So I need products of 1 times 48, or factors of 1 times 48 that add up to negative 14. So I kind of think, off to the side, I have negative 48. That would split apart to, I could do negative 24 plus 2. We want to see, does it equal AC? Does it equal B, right? Add to B. My B was negative 14, right? So does this add up to negative 14? It's going to be actually negative 22. So no go on that one, right? So we just try a different set. Now we could try, let's try negative 6 and positive 8. I know I need to have different signs, right? A negative and a positive, or vice versa. So we're going to try negative 6, positive 8. If I add those together, I wrote this wrong. This should be a plus 48. Sorry about that. That's a plus 48. I don't know what I was thinking, but that happened. So, nonetheless, let's look at the factors here. We still need negative 14. 24 and 2, if I added those factors together, I would get a positive 26. So still no go. Now, if I do 6 and an 8 positive, I would get a positive 14. So I'm getting closer. But positive is not working. I need to have that middle term be negative. So I'm going to try negative and negative in here. Write that red. I'm trying to show you like the thinking process here. So if you get this, just feel free to skip through that. But negative 6 plus negative 8, that would give me a negative 14. So these are good values to try in there. So I have a minus 6 and minus 8. I know this first one It's just x and x because I have a lead coefficient. So now when I FOIL, I have to always check it. So I have x squared, I have minus 8x, I have my inside here is negative 6x, and my last is plus 48, which I needed there. And then when I add those like terms in the middle, I get my middle term back. Good to go. But then again, try to kind of clean this up. Leave your trials and errors, like leave this, and then, you know, just mark your answer clearly. And so I know, and that's your verification there. Okay. So trial and error is a nice, quick process, but you always have to check. Now, sometimes we come across a case like in example 7.16 where we can't factor it with, you know, a real number, integers, it's just not going to work out. So we call that prime, or we say not factorable. Don't leave it blank. Make sure you write the word prime or write not factorable. Because factors, when we're factoring, we're looking for integer values here and here. Typically, later when we get to, you know, math 99 and math 141, there's a whole square root situation we can do too, but this, for our purposes here, we're just doing real numbers, we're doing integers on our factors. Okay, so if I go to factor this, a squared minus 4a minus 6, and I'm looking for some real integer, actually not, I mean, integers are subset of real numbers, so we're good there. And I'm trying to do a times a, and then I know I need to have a plus and a minus because this is a negative. And I think, oh, I could just do, let's try 3 and 2 and see if I could get 4a. So I just try some numbers and I look, 3a minus 2a, that would give me just a plain a. It's not equal to negative 4a is which I need. So that doesn't work, right? So then I try a different one. I could try what are combos of 6 that add up to 4? 6 and 1. Maybe I could try switching the signs. Really, then I just get it. You know, I'm never going to get that negative 4a. There's pretty limited factors of 6 here, but I could try a positive 6 and a negative 1. Let's try this, 6a and negative a. That would give me a 5a, still not my negative 4a. So again, out. So show the trials and then you're going to say prime. Okay, but make sure you do show that you've thought about it. There's really going to be no factors of 6 that add up, of negative 6, that add up to negative 4a. Okay, now we're looking at page 95 of your workbook, 7.2.2, and we are going to discuss factoring out common factors first. So if you have a trinomial like this one in example 7.17, and it says factor 7x squared plus 21x minus 70, I always want you to look to see if you can have anything common to every single term, though. You can't just pull it out of one and not the others. So again, later in higher math, we sometimes do different things and manipulate stuff a certain way, but like for completing the square. But in this case, we are just looking, does it go into every single term? And there is a number that does go into every single term, and that would be 7. So I'm going to factor that out first, and then just rewrite the rest for now. So I get 7 times quantity x squared plus 3x minus 10. Okay, and just kind of double check that's right. Now I want you to factor this trinomial. You can do that as classwork. The thing you need to know what to do with the 7 is just bring it down, and you're gonna just leave that right outside your parentheses. So if you're doing the skeleton method here, just not by grouping, we're just doing intuitive method for this one because we have a lead coefficient of 1. It's really kind of the same thing in essence. So we're going to look at factors of a times c, which would have negative 10, that add up to 3x in the middle. Okay, so this is AC, and we want to add up to b, which is going to be a positive 3. Okay, so if we look at our options here, first we want to know that we have a lead of 1, so we can do x and x. We know we need to have opposite signs because that is a negative 10. Okay, so I'm double checking. So I know I'm going to have a plus and a negative, so you can kind of think about that. And then I'm just going to try random things like a negative 10 times a 1. If I added those together, I'm going to get a negative 9. So that is out, right? It's not equal to 3. I'm looking for 3. Okay, so if I have, then try, what are my other options? I have 5 and 2. So let's try a negative 5 and a positive 2. If I actually add those together, I end up with a negative 3. So still not quite what I need, but it's close. So let's just change it to be a positive 5 plus a negative 2. Okay. And then I will get a positive 3, and bingo, I'm good. So I'm going to write those in here, x plus 5 and x minus 2. And then again, just always verify. So you're going to mark your answer, and then you're going to verify. Leave your trials, don't erase it, just in case something went awry. I know what you worked at, and you weren't just plopping any old thing down, but we're going to carry that 7. Then we have x squared first, right? And then we have outsides, which would be minus 2x. Inside is plus 5x. And our last is going to be minus 10. So we're double checking all our signs are right. So we have 7 times x squared plus 3x minus 10. And then finally, we want to distribute that 7 back. 7x squared plus 21x minus 70. And we are good because we have a match. Okay, that's the same. Now, the last one of this section, example 7.18, might look a little scary at first because it's got a lot of stuff going on. But if you look to see if there's anything common, there is. So I can pull out a 4. I can pull out the smallest exponent of x, so that would be x squared. And then I can pull out a y. And then let's see what's left. So then we're left with just x squared there in that first term. So just to read through this, I should say where I'm starting. 4x to the 4th y plus 36x cubed y squared plus 80x squared y cubed. So now we pull out the 4x squared y times quantity x squared plus 9x y plus 20, and then just the y squared on the end. So it should look familiar to a problem you've done before. Again, we're just going to carry this 4x squared y down, write our parentheses, So you can pause and do that for classwork. Again, just try that on your own. And I'm going to pop in here the x and the x because I know I need an x squared. Then I know I have all positives, so that's nice. I can just put a plus plus. I also know that I need these y's on the end, right, to get my y squared. So now I'm just kind of looking at, do this in a lighter color, what, and this is one, products of, or factors that make a product of a times c, which is 20 in this case, plus 20, will give me a sum of b, which is a positive 9 in this case. So I'm looking at 5 and 4 just pops out to me. 5 plus 4, that does in fact equal 9, so good. So we can just go ahead and put those in and then check it. So I end up with x plus 5y as a binomial times binomial x plus 4y. Now I'm just going to do my verification. Do you want to box that in or mark it as my answer? I might have to go back and change it if something went wrong with my verification, though. Like, don't be afraid to do that. You definitely want to fix it if it's not right. So carry down that 4x squared y. Then we have x squared for our firsts, our outsides 4xy. And get real good at multiplying your polynomials. And then plus 5xy, and then last are plus 20y squared. Again, this becomes, right here, this becomes our 9xy. So I'm not going to rewrite that all again. And then I'm writing 4x squared. I'm going to just distribute here, actually, instead of rewriting all that. So I'm going to have 4x squared y times x squared is going to give me back the 4x to the fourth y. Then, so it's that one. Then I'm going to multiply by the 9xy. So 4 times 9 is going to give me my 36. And then I have x squared times x is x cubed. And then y times y is y squared. So I get that middle term up here. That's good. And then I'm going to distribute to the last term. So 4 times 20 is my 80. X squared times just no x's over there. So that's just x squared. And then y times the y squared is y cubed. And that gives me my last term here. So my verification is good. And then just, again, make sure this is the answer and you mark it clearly, because if I'm grading and I'm bouncing all over the place, just takes me a long time to grade as it is and giving partial credit. So I really appreciate when answers are marked clearly and it's not ambiguous, and I know for sure. So that is it for section 7.2. I know that's a lot to work with, so process through your homework. 7.3 is going to be quite a bit more challenging, but once you practice this and just give it some time, you'll get it. We go over it again in Math 99. We review it pretty comprehensively. So just try your best and stick with it. Have a great day.